So life's pretty good for old Max right now. I got two bitchin' GPZ 900s or Ninja 900s, depending on who you ask, to work on, and I'll probably be fixing them up sometime next month. Not too bad. Just got my first job as a paramedic here in town, so I'm in training right now. Enjoying that. Looking forward to getting out on the road by myself, render some medical care, and my awesome little brother got me a GoPro for Christmas. So we can look forward to some pretty high quality action shots. I don't have to hold the camera in my mouth anymore, and hopefully I'll take you guys along on some rides. We've been finding some really pretty roads out here in Sacramento, so that'll be cool. But today we're going to be talking about batteries. I have a couple of videos up about batteries, just real introductory stuff. The XJ550 is down for the count currently because the new battery that we put in it was a piece of shit, and so really explaining to Chris why the bike wasn't starting and why we need a new battery got me thinking about batteries and the job that they have to do in starting the bike up, and so I'm gonna just make a little movie about it. So here we have two batteries, a big one on the left and a small one on the right. The one on the left is a type of battery that you probably use in a Goldwing or some big bike like that, and the one on the right is the type of battery that I used in the CB200 Cafe Racer. They're both 12 volts. Pretty much all motorcycles made in the past, 30 or 40 years are 12 volt systems, just like cars. The difference here is, obviously, the size and the weight and everything, but the electrical difference here is the number of amps that they put out. The one on the left here puts out 18 amps, and the one on the right only puts out 8. A really easy way to remember the difference between volts and amps is volts is the pressure. If you can think of it like water, volts is the pressure and amps is the volume. So which is why like a taser, which can put out tens of thousands of volts just like your spark plug, can be powered by an itty bitty little battery like the size of a 9-volt, because they need very, very small number of amps but very high voltage. Consequently, a taser could not power like a starter motor on your motor. There's just not nearly enough amps. Now when you start up your motorcycle, it truly is a Herculean effort by the battery to innervate all kinds of things at once. Your battery has to do a million different things, and it really is impressive when you come down and think about it. So I'm just going to sort of illustrate everything out here like I usually do. Here we have our battery, right? And you got your plus and your minus. Okay. Now this is going to go to your starter solenoid. And this is just a little electromechanical switch. When you press your button, this switches up. I've gone over it in other videos. It really doesn't take very much electricity at all. It's a very, very simple thing. But as this energizes, you have, this lead obviously goes to your starter motor, but you also have power leads, and that'll go up to like your headlight, and then it will go back to your tail light, and it will also go up to your gauges, and it will turn them on. And a lot of bikes have like an idiot panel or a indicator panel, and you've got your oil light and your neutral light and your high beams, and they all turn on. So even before you start your starter motor, your battery is already turning on all of these lights. So really that's not such a big deal. I mean, I'm sure a lot of you guys have left your bike on but not running, for some time, and you know that just our small battery, just one of these can keep these lights lit up for quite a while. And this starter solenoid takes almost no energy at all. Not really that big of a deal. The really impressive stuff comes when you start getting towards the starter motor. The starter motor runs down here, and it's this cylindrical thing here, and it takes a lot of power. It's a very high torque motor because it has to move your motor, the engine of your bike. It has to move it from a stopping position and overcome all that inertia in order to start it, and in order to start it quickly, because there are a whole lot of things that need to happen at a certain speed in order for your motor to actually start. So what you have here are these really thick wires, and they go from your battery. You've got, a thick one that comes off here and that grounds out, but you have these thick ones here that go here, and usually these are as short as possible. That's because with an increased length in your wire, there's going to be increased resistance, and more of your heat, or more of your electricity, is going to be transferred into heat. Now, what you have here in battery is just basically a collection of chemical energy, and it gets transferred into electrical energy, which gets transferred down here into kinetic energy. Now, guys, stop me if I'm, messing up here. It's been a long time since 10th grade physics class, but all these transference of energy from chemical to electrical to kinetic, they all have byproducts of heat, and that's just wasted energy that the battery has to waste. And it's just a factor of transference energy. Every time you transfer energy to something, some is wasted. And that's all shed in heat. And so that's all wasted. So your battery has to be strong enough to overcome all this wasted heat. Your head bulb is making heat. All this is making heat. Every single electrical connection, if you have one right here, for example, where two wires meet, that's going to get hot, and that's going to be wasted heat. Even if it's a brand new connection and it's as good as it's going to get, some heat is going to be wasted there. And so that's happening all over your bike. Your bike is radiating heat all over the place. It's not necessarily perceptible, but it's wasted energy. So your battery has to overcome that. Alright, so we've got these thick wires here. They're usually pretty thick, and they're as short as possible. On some bikes, like for instance the XJ550 I just got done working on, this wire from the solenoid to the starter motor is pretty short. It was only maybe 8 inches long. However, if you're working on a Virago, for instance, it's much longer because it has to go all the way to the other side of the motor, and because of where the starter motor is placed. So whenever the wire is longer, there's going to be increased resistance. So they try and make it a good thick wire to help it out a little bit. And also, big bikes like Viragos, they need big batteries like that. That's why this dinky little thing just wouldn't be able to cut it. So, we've got all this effort so far. We're only to the starter motor. Now, the starter motor is connected by by a chain or by idler gears or whatever. It's connected to your flywheel somehow. So let's say we've got an inline 4 motor. You got your transmission here, okay, and let's say here's your flywheel or whatever. You got your pistons that come up, and you got 1 piston, 2 piston, 3 piston, and they go back into the motor like this. You have your valves here, okay, and then you got your head, and you've got your cam, which is going around here, and there's like a cam chain type of thing. You got all this, right? Here's your sump, and this is all full of oil, okay, and then you got your carbs, and these are your carb boots, and then your rack of carbs sits off here, and these slide up and down, and then you have your air box with a little filter element inside. Okay, so we got all that, right? Now your starter motor is connected to your flywheel, and as soon as you hit your button, I should actually give you a button to hit. Let's see. All right, we got your handlebars here with your levers, and here's your starter button that sits right here. Okay, as soon as you hit your button, that's going to flip your switch, or your starter solenoid. Your your starter motor is going to start to turn over. It has to turn over super rapidly, and that is so that enough air is drawn in to the airbox, flows through the carburetors. It picks up its particles of gasoline, goes through the boots, through the intake valves, and into the cylinders. That is because the gas that's already in the cylinders, the gas from last night, which is all cold and condensed on the walls of your cylinders, it's not really all that combustible. What you need is atomized gas that's all in the air. If it's condensed on the walls and in a liquid form, it's not going to combust very well. That's why you have a choke system anyway, to enrich in that and put more atomized gas in. So anyway, you need your pistons to be moving up and down and creating that vacuum fast enough. Oh man, I forgot about the exhaust system. All right, you got your exhaust pipes, right? And they go out like this. You got big megaphone exhaust because you're a badass. Look at you. Bam, bam, bam. Whoops. There you go. Bam, bam, bam. Because you're awesome. All right. So anyway, you gotta pump this fuel-rich air in. So it goes down, comes up. Maybe it combusts, maybe it doesn't, and then it has to be pushed out, and it's got to be pushed out through your emission system if you have one or whatever. Or if you have straight pipes, good for you. Pushed out through a muffler. So all this, your pump or your motor has to do this at a certain rate, or it's just not going to pull in enough fuel to combust. You're just not going to have anything to burn. And so your starter motor has to get this whole rig going, and it has to get it going really quickly, and it has to get it going at a certain rate. Now, what's working against the starter motor? A shit ton of stuff. First off, you have all of your oil down in here, and it's all up in your oil passageways or whatever, and it's all cold and thick and grumpy, and you live up in Minnesota, and so it might as well be molasses, right? And so your water or your oil pump, is down here somewhere or whatever, and it's struggling, to pump all this up, and it's connected to your flywheel, and so everything starts pumping at the same time, and it goes pump, 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 and so that's power, that the starter motor and consequently the battery has to provide. And remember, if you're transferring kinetic energy here to kinetic energy to a chain, to a gear and everything, there's heat. Just like heat was lost all in here, there's heat being generated and lost, so that's all wasted energy. So yeah, the oil's got to get going. The oil's not, very warm yet, so it's thick. If you have a water-cooled bike, maybe you have like a radiator here. You've got water going through this whole thing, and so your water pump has to get going and start moving again. And that's not such a big deal as the oil pump, but it's still effort. It's still effort that has to get going. Consequently, your pistons are pushing up against the pressure inside your cylinders, 120 to 180 psi or whatever, and your exhaust valve is dumping that pressure into the pipes every now and again, but it still has to reach that point. It has to reach your maximum compression. So there is always a time that that one or more of your cylinders is pushing up and trying to achieve 140 psi, let's say, and so that's a ton of effort. If you guys have ever kickstart a bike or had to rotate your flywheel by hand, there's a good amount of effort required in it, especially too if you have a V-twin engine which only has 2 cylinders, or God forbid even a 1-cylinder engine. I know my XT550 is a bitch to kick over because all that pressure is being generated by one cylinder. It's not being dumped out until the exhaust valve opens up, and so I have to when I kick it over, I have to generate all that pressure all at once, as opposed to some being dumped out and some being made up again. So your starter motor has to overcome all of that, and it has to do it at a certain rate in order for for your gas to be drawn in or whatever. Okay, as if that wasn't difficult enough, your battery has to create a spark your spark plugs, you know, go down in here through the top. Let's put 2 up in here. And then there's a coil. And then these wires here. And then it gets input. And you got your CDI. And there's trigger coils. And there's pickup coils and all that stuff. It takes energy from the battery, goes into, you know, some kind of a condenser or whatever. It just, you know, there's a lot of different ignition systems out there, but mostly they you know, they pretty much all take electricity from the battery or from the magneto if it's like a you know, a small dirt bike or whatever that doesn't have a battery. But we're not talking about bikes that don't have batteries on this battery video. Anyway, you know, it takes energy in here, it goes through here. The battery has to power the CDI, which is like an itty bitty little computer, and that tells, you know, when to release the spark. And then this super high voltage spark, you know, tens of thousands of volts, it's crazy, comes out here and it fires, and it needs to, you know, it needs to fire the spark plug, which is a big part of igniting your bike. If you don't have enough power, let's say your battery's all, you know, the power is all used up in trying to move this massive machine with, you know, with gears and sprockets and push rods and compression and all that shit. If it's too busy doing this, and if it's worn down from doing this, then it's not going to have enough power to make that voltage and ignite that gas. So that's why sometimes, you know, if you've got a low battery, you can crank and crank and crank and crank it, and it will move the motor around. You know, it'll have enough amperage to push all this stuff around, but it just won't have the power to produce that spark. And so that's, you know, that's one reason why you need a really good battery, because it needs to do all these things all at the same time. And while it's doing this, there's all kinds of little ancillary things too. Like, let's say you have a kickstand switch. Okay, you got your kickstand here, and there's this switch that that makes sure that you know, that your kickstand is up or whatever, or, you know, you're in gear or whatever. You've got a neutral switch, or you've got a clutch switch. You know, oh, your clutch is up here. You've got a clutch switch that makes sure that your clutch is pulled in so you don't start your bike in gear. Or you've got a kill switch, you know, which makes sure that the kill is in, and so then there's a circuit that goes through it and then comes back. On some bikes, the kill switch actually completes a circuit, which is required to start the bike, and sometimes it interrupts the circuit, you know, like interrupts a circuit down here. So for the ones that it interrupts, it's not such a big deal, but for the ones that it completes, then there's, you know, electricity has to travel all the way up through here, go through the switch, and then all the way back down again. And, you know, that's wasted energy, that's wasted heat that comes off here, you know, and just like I said, the clutch, same thing, you know, a neutral switch, a kickstand, all these things are tiny little electrical circuits that the bike simultaneously has to overcome with a good strong battery. So you can see there's like 1,000,001 things that the battery is asked to do every time you turn it on and hit that that starter button. That's why, you know, in the wintertime when these things just get a little bit weak, everything goes to shit. For some bikes, you know, some bikes are a lot hardier on it. They can start with a weak battery. Some bikes you gotta have a really strong battery. So next time, you know, you're looking at your 2 or 3 year old battery that you got at Walmart for $30, and you're thinking, oh, you know, this piece of shit, you know, why won't it ever start my bike, da 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 da. Give it a little bit of credit, because the battery probably has the toughest job in the entire motorcycle.